All right, so in this set of guided notes, we're going to cover the first two sections of your Algebra 2 textbook, which is really a bunch of review stuff from Algebra 1, but you probably haven't thought about it since you were in Algebra 1. So let's do this. Now, for these first the definitions, which are expression, equation, and inequality, I'm going to speak the definitions out loud and repeat them, but I'm not going to write them down because that'll take a little more time in the video. So an expression is a mathematical sentence containing one or more variables. That's a mathematical sentence containing one or more variables. And an example of an expression might be like 2x plus 5, or n minus 15 over y, or x, y, z. All of those are examples of expressions. Now, an equation is a mathematical sentence stating that two mathematical expressions are equal. That's a mathematical sentence stating that two expressions are equal. So an example of that might be 2x plus 5 equals xyz, or n minus 15 over y equals 12. An inequality is a mathematical sentence stating that two mathematical expressions are not equal. And in math, there's several different ways of expressing that things aren't equal. You could say that 2x plus 5 is less than xyz, or less than or equal to. You could say that n plus 15, let's just change it, over y is greater than 12 or greater than or equal to. And you could just say that, say, 2x plus 7 doesn't equal 12. And those would all be considered inequalities. Now, whenever we're working with expressions, typically you're asked to simplify or evaluate expressions. And to know the difference between those, simplify means combine everything that can be combined using the rules of Pemdas. We're going to talk about that in a second. Evaluate means when you get to the end, you're doing the same thing, the rules of Pemdas, but you're going to end up with a number at the end. Evaluate means you want a number answer. Simplify means you want to just combine everything as much as you can. Meanwhile, with equations and inequalities, we're often asked to solve those, and we're going to talk about that in just a moment. Now, when you're simplifying or evaluating expressions, we always do that in PEMDAS order, and that is the order of operations thing, which you should have been practicing in a little bit in the 4-4s activity. Now, PEMDAS you should know, but let's make sure you do. The P stands for parentheses. And that could be any grouping symbol: brackets, braces, a fraction bar, a square root sign. There's several different ways of having things grouped together. E stands for exponents. So you would do parentheses first and then exponents. Then M and D are multiplication and division. And these two are on the same level. So if you have an expression and you're reading it from left to right, you would always do whichever thing you come across first going from left to right. It's not multiplication, then division. It could be division and then multiplication. And then the A and S are addition and subtraction. And again, those are on the same level because basically they're the same operation just in reverse. All right. So using those rules of PEMDAS, I would like you to evaluate this expression here and simplify the expression to the right. So I'm going to ask you to pause the video, try that out, and then unpause it to check your answer. So first we would do parentheses. Then we would do exponents. Then we would do multiplication and division, left to right. And then we would do subtraction and addition, left to right. And notice the answer is a number. That's what we'd find when we were evaluating. So let's look at the simplification problem. Do it, and then pause the video and check your answer. We start with parentheses, but we can't combine those things in parentheses because they are not like terms. So then we're going to look at exponents, but there aren't any exponents. So then we're going to move to the multiplication and division part. Remember that involves the distribution property, and remember we're distributing a -4 here, so it's going to change the signs back here. And now we're going to add and subtract by combining like terms. Notice in this case we can't combine anything that's left, so this is as simplified as it can be. And this would be the evaluation. Now, whenever we are solving equations or inequalities, we have to undo operations. So instead of like doing PEMDAS, which is what you do when you're doing the operations, that's the order of operations, when we're undoing them, we undo them in what's called reverse PEMDAS order. which means if we're looking at an equation, we would undo the addition and subtraction first, then we would undo the multiplication and division, then we would undo exponents, then we would undo parentheses. But whenever you're solving, the first thing you do is you simplify as much as possible using Pemdas, and you would do that on each side, and then you solve using reverse Pemdas. So let me show you what that looks like in this first example. So first of all, we're going to simplify. So we're going to start with parentheses, but we can't combine the things in parentheses. We don't have any exponents, so we're going to skip down to the multiplication step. Then we're going to combine like terms on the left because we still have something we can simplify. Now we can't combine anything else on the left, so it's fully simplified. The thing on the right is also fully simplified. So now we're going to work on solving for x by doing reverse PEMDAS to the stuff that's on the x. So we're going to undo the subtraction first, and then we're going to undo the addition and, the multiplication and division. And you should always simplify your answers. Cool. So now if you look at the bottom problem says to solve for y. So what we're going to do again is we're going to start by simplifying as much as possible. We can't do anything to the right-hand side, but the left-hand side, since we're dividing a sum by a number, we can go ahead and, let me zoom in on that a little bit. There we go. We can go ahead and do that division. I'm going to go ahead and distribute that negative that was in front of the fraction now. And now I have a y on both sides. So essentially, I'm asking you to solve for y. So whenever you're asked to solve for a variable and that variable appears in more than one term, you kind of want to get all the things that have that term on one side and all the things that don't have that term in another. So I'm going to do that in 2 steps. I'm going to move the stuff on the left-hand side that doesn't have a y over to the right, like that. And then I'm going to move on the right-hand side, the thing that has the y, over to the left-hand side, because that's where I want all the y stuff. And remember, -8/3 and -5, when you're adding those together, you would need a common denominator. That's where the -23/3 came from. And now I want to get y by itself. I could do that in one step by dividing by -23/3, but sometimes people, when they're working with dividing by fractions, get confused. So I'm going to undo this in 2 steps. I'm going to multiply both sides by 3 to get rid of the fraction. And then I'm going to get the y by itself. Now, this would be an acceptable answer, or you could also write it, you know that thing where we split in the earlier step, we split the fraction apart. You could also do that here if you wanted to. But either one of those would be an acceptable answer. So when you're simplifying an expression, you follow PEMDAS order. When you're solving an equation, you simplify each side following PEMDAS order. And then when you're solving for a variable, you work in reverse PEMDAS order to undo operations.